All right. So now this is a question that someone has asked. Yeah, so we can try by all means. Let's try to go through it together. So now this is an order reaction, specifically on cyclization, changing this cyclic form into this other form by adding this alpha beta unsaturated carbon containing compound and add it to that one. So when adding this, or let me just say this is an alpha beta, because here this is a ketone. When you look at this is a ketone. So now the carbon just after the functional group of the ketone is an alpha, then this is a beta. So when you add this alpha beta to that one, you can have this compound. How? Let's try to look at this mechanism now. This is the mechanism that we are going to look. First of all, we need to make an ion which is called an enolate ion by so an enolate ion is a negative charge, or an ion to you make an enolate ion on the alpha carbon of this form. That's the one that is an enolate ion is going to be added to the alpha beta of this reaction. So how now? Let's go now together. So now here, this is an alpha, this is a beta, because a carbon after a functional group is an alpha of the ketone. This is the beta, then this is an alpha, then this is a ketone, and this is an alpha. So look at this reaction. Where is it added? When you look at that one, we can see that this compound is here, which is here. Then something was added from there. So what am I going to do? Here there is hydrogen here. So that is the one that I'm going to remove and make an ion. When you remove a proton, the compound that is formed is, when you remove a proton, it will become an ion. So now I've been given this, which is OH. That's the one that I'm going to use. And this down, which is here, it is a solvent, or the solution where this reaction was taking place. So this is an OH that I'm having right now. This is an OH that I'm having right now. Let me just remove it and do this. So this is an OH that I'm having right now. So now I'm going to get this hydrogen here of the alpha. Don't forget, we always attack the alpha, then and make an enolate ion. So this bond will go like that one. So what am I going to have? I'm going to have something like this. Then CH3, then here there will be a negative like that one, then here there will be something like that. Hope you are following. That is an enolate ion that we have formed. So now an enolate ion is going to be attached to this compound, which is an alpha beta unsaturated carbon containing compound, on the alpha carbon. So now let me just write it. So this is H3, like that one, like that one. So I'm going just to get this one the way it is. Then here it's like this, like that, like that. So that's the way it is, like that. So I'm going to get this enolate ion, and it attaches itself on the beta of this one. So what will happen, that this bond will shift to here, or this when this attaches here, this double bond to shift to this, and this guy will remove this hydrogen bond, because what we want is to have 4 bonds on the carbon, but here they are 4, but when it comes a double bond here, they'll become 5. So this one has to open to leave to become a single bond. So what will happen, that this bond now will go to this, or shift to that. How? So I'm going to have something like this. Like that. Then here to be something like this. So this enolate ion has added itself to the beta of this. That is one which is called the micro addition. That is micro addition. So when it is attached to that, it will make a sigma bond. In other way, we say a single bond. So now I will just make a sigma bond here, attaches here. Then I'm going to start from here. Remember, this bond has broken. That is this bond now. Then here it has made a double bond. that is this double bond like that, then you can see that this one has opened and it has only one with a negative because it has lost one bond. Then with this now, it will be something like this, CH3 like that. Okay, so now when we reach at that point, I'm just going to draw like this one, CH3, to be something like this, so something like this, then CH3. So now when you reach at that point, we can say, okay, so which one will I get? We can say, have you seen here, this one, it has got a double bond on this here, which is the oxygen, but here there's a single bond and it's not stable. So what am I going to do? We are going to say that this will go back here. When it go back, it will form a double bond there to that carbon, but it will have 1, 2, 3, 4, 5. So this double bond which is here has to go. How? This now, which is you remember when we on OH get hydrogen there, it was something it has made some water. So it has made some like this one, which is or let me just do like this. I can just light the way water is written like that. See, it's like water like that. So now this water or this double bond here has to go because it has 5. This carbon has got 5 bonds now when this comes back here. So this double bond here, it will go. And so what will happen is that let me just remove this. Okay, so now this will go and get a hydrogen to be added there so that it can be stable. So this hydrogen will be gotten. So what will happen? It will go like that. It will be an OH now. So this bond will come and get this hydrogen and add it to that so that this bond can go. Then what are we going to have like that? So we're going to have something like this. So something like this. Something like this. Like that. Then here it will be something like this. Okay, so I hope we are following. So this double bond has gone because we have added this hydrogen. I've gotten this hydrogen and we have OH now. We only have OH. So when we reach at that point, we are going also to make an enolate ion on the alpha of this one so that it can be attached itself where this point. So now what am I going to do? Hey, I lost my pen. Okay, so it will be something like this. Okay, like that. So now let me just remove this and put it like this. So when I reach there, I'm going to say I need to make an enolate ion. Have you seen that this is just CH3, but here CH2 then with H. It's the same as CH3. What I want is just to make this one easy to attack on the alpha of this one so that when this has become an enolate, it will come and attaches itself there. So what will happen is that I'm going to get this OH which has been formed there, and I'm going to grab this hydrogen there. What will happen? This bond will go and it will form an enolate ion. So it will be like this. Like that. Then here, let me remove it. Like this. Then here it will be CH2 with a negative like that. or you can just put a negative to show that it's an annullate ion. So at the point where I've reached, I don't know where I can write. Let me just rub on top. Hope we are following. Let me just rub on top. Okay, so I'm going to write there. So at the point where I've reached now, I'm going to do like this. What am I drawing? Like a person, eh? Okay. Like this. Like this. So I shouldn't forget something like this, which is here. I shouldn't forget that. So there is something right here. So it will be attached itself. So like that. So on here it will be something like this. Then here there will be an annullate ion, which is this one now. So what will happen there now? We are going to say this an annullate ion has come to attach itself there to make this ringed form like that. Then this, it will have now 5 bonds. What will happen to that one? It will open to form an ion. So I'm going to write it like this now, the one that I'm forming. Then with here, so here there is CH3, then like that one, like that. Then here there will be something like this. Hey, 11 minutes, something like that. Then here it has attached itself, it has made the sigma bond like here. Then here there will be an ion like that. Then when I reach there, I'm going to say that when I reach there, I'm going to say that this is an OH, this is an oxygen, but I want it to be OH so that it can live, at least to be a living group. Since OH again is a bad living group, but it will live with the presence of heat. So I'm going to bring this. Since this one, when it grabbed the hydrogen, so it will be water. It will be water. So it will be something like this. It will be something like this. It will be something like this. Water, something like that. So it's going to add this one. We'll get this hydrogen. So let me just do this. I like changing colors so that it can make sense. So this one will get this hydrogen, then this bond will break like that. Then it will be an OH now. So I can also label this part here. Okay. So now, when it is an OH now, it will be like this. So here it will be CH3, don't forget. Then here to be something like this. Then here to be an OH like that. Then I'm just going to introduce heat. More heat will be introduced. So what will happen is that when I introduce more heat, this it will live on its own, because here it is a bad living group. I don't need to protonate it, but I'll just include heat so that this guy can move or can live on its own. What am I going to have? I'm going to have something like this. Sorry, don't forget here there was something like this here. So here, so here to be something like this, then something like that. Then here there will be CH3 like that. Let me just so here have I removed heat, then this one has moved, so it will be something like this. Then here CH3, then here like this one, like this. So that's the one that I've formed now. That is the product that I have formed. So now remember, here there's a double bond. Now I'm going to apply that concept of elimination, but to attack the alpha. So which one is the alpha here? This is an alpha which has got 2 hydrogen here. So that's the one I'm going to attack using the elimination method. How? I'm going to get, since remember that this one, when we added hydrogen there, when we added hydrogen to this compound, we had something like OH which has remained. So this OH now is the one that is going to grab the hydrogen. So this OH is the one that is going to grab this hydrogen like that. Then this bond will come and form a double bond there. Then that is the product that is going to be formed. So it will be something like this. Or let me just remove this. Okay, so it will be something like this. That's the last stage. Eish. That's the last stage. So here it will be something like this. Like here. So here, as I said, that I'm going to use an elimination method by attacking the alpha, not any other, like using a Z-save word, but I'm going to attack the alpha. So here there are 2 hydrogen, so that is an alpha carbon. So now I'm going to get the base, which is an OH. Remember that when we are forming this OH here, this was water, but this was grabbed and we have just remained with an OH. So that is the one that I'm going to get right now. I'm going to get this OH here, like that one. This is the one that is going to grab this hydrogen. Then this bond will come and form a double bond there. So now what am I going to have is something like this. Like this. Like this. Then with a double bond there. Then when you look at that, that is exactly this. So mostly it comes with 8 marks or 6 marks. You need just to follow the concept. Thank you guys.